Picture this, a swirling cosmic masterpiece, over 30 million light-years away, where stars are born, black holes lurk, and mysteries abound. This is the Whirlpool Galaxy, a celestial wonder that has fascinated astronomers for centuries. But what makes this galaxy so extraordinary? Why does it stand out among the countless others in the universe? The answer lies in its secrets, 30 strange phenomena that defy explanation and challenge our understanding of space itself. From its colossal black hole to its mesmerizing spiral arms, the Whirlpool Galaxy is a treasure trove of cosmic enigmas waiting to be unraveled. In this video, we'll take you on a journey through these mysteries, revealing why this galaxy is not just another dot in the sky, but a window into the universe's most profound questions. Stay with us because by the end of this exploration, you'll see the cosmos in a whole new light. Ready to dive in? Let's begin. Now, let's zoom into the very heart of the Whirlpool Galaxy, where one of its most awe-inspiring features resides, a supermassive black hole. This colossal entity isn't just a void in space, it's a gravitational powerhouse millions of times more massive than our Sun. Its immense pull doesn't just hold the galaxy together, it actively shapes the entire structure of the whirlpool, influencing the movement of stars, gas, and dust around it. Surrounding this black hole is something equally fascinating: an accretion disk. Picture a swirling, glowing ring of superheated gas and dust spiraling inward at incredible speeds. As this material gets closer to the black hole, it heats up, emitting intense radiation that can be seen across vast distances. But that's not all. From the poles of this black hole, powerful jets of particles shoot out at nearly the speed of light. These jets stretch far beyond the galaxy itself, carving their way through the cosmos and leaving a trail of energy in their wake. What's truly mind-blowing is how this black hole isn't just a destructive force. It's a cosmic sculptor shaping the galaxy's evolution over billions of years. Without it, the Whirlpool Galaxy as we know it wouldn't exist. So, while black holes might seem like the ultimate cosmic vacuum cleaners, they're also the architects of some of the universe's most stunning structures. And this one at the center of the whirlpool is no exception. But the story doesn't end here. As we move forward, we'll uncover how this black hole's influence extends far beyond its immediate surroundings, setting the stage for even more cosmic wonders. Now, let's turn our attention to one of the most striking features of the Whirlpool Galaxy, its breathtaking spiral arms. These sweeping arcs of stars, gas, and dust aren't just beautiful to look at. They're dynamic regions where the galaxy's most dramatic events unfold. But how do these spiral arms form, and what keeps them so distinct and prominent? The secret lies in something called density waves. Imagine a cosmic traffic jam, where stars and gas clouds slow down as they move through these waves, piling up and creating the bright, dense regions we see as spiral arms. These waves don't move with the stars. Instead, they ripple through the galaxy like waves in a pond, compressing material and triggering bursts of star formation. It's this process that gives the arms their glowing, star-filled appearance. But there's another invisible force at play here: dark matter. This mysterious substance, which makes up a significant portion of the galaxy's mass, plays a crucial role in shaping and maintaining the spiral structure. Dark matter's gravitational pull helps anchor the density waves, ensuring the arms remain stable over billions of years. Without it, the whirlpool's iconic shape might unravel, leaving behind a far less organized galaxy. These spiral arms aren't just static features, they're stellar nurseries where new stars are born in vast numbers. The compressed gas and dust within the arms provide the perfect conditions for star formation, lighting up the galaxy with young, hot stars. Over time, these stars drift away from the arms, but the cycle continues, with new stars constantly being born to replace them. What makes the whirlpool's spiral arms so mesmerizing is their balance of chaos and order. They're regions of intense activity, yet they maintain a graceful, almost rhythmic structure. It's a reminder that even in the vastness of space, there's a delicate interplay of forces that shapes the universe in ways we're only beginning to understand. As we move forward, we'll explore how these spiral arms interact with other phenomena in the galaxy, revealing even more about the whirlpool's intricate dance of creation and destruction. Now, let's zoom in on one of the most vibrant and energetic aspects of the Whirlpool Galaxy, its star formation hotspots. These regions are like cosmic factories, churning out new stars at a pace that far exceeds what we see in most other galaxies. But what makes these areas so special, and why do they produce stars at such an extraordinary rate? The answer lies in the perfect storm of conditions found within these hotspots. Dense clouds of gas and dust compressed by the galaxy's spiral arms create the ideal environment for star formation. When these clouds collapse under their own gravity, they fragment into smaller clumps, each of which can ignite into a new star. The process is fueled by the abundance of raw materials, hydrogen gas in particular, that accumulates in these regions, often triggered by the density waves we discussed earlier. But it's not just about the materials, it's also about the energy. Shock waves from nearby supernova or the gravitational pull of passing stars can further compress these gas clouds, accelerating the birth of new stars. In some cases, the sheer density of these regions leads to the formation of massive stars, which burn brightly and live fast, shaping their surroundings with intense radiation and stellar winds. Astronomers observe these star-forming regions using a variety of tools and techniques. Optical telescopes reveal the glowing gas clouds and young stars, while infrared observations pierce through the dust to uncover hidden nurseries where stars are just beginning to form. Radio telescopes, on the other hand, allow scientists to map the distribution of cold molecular gas, the raw material for star formation. Together, these observations paint a detailed picture of how stars are born and how these hotspots evolve over time. What's truly fascinating is the sheer scale of activity in these regions. In some parts of the Whirlpool Galaxy, star formation occurs at a rate hundreds of times faster than in our own Milky Way. This makes these hotspots not only a key area of study for understanding star formation, but also a window into the galaxy's past and future. The stars born here will shape the galaxy's evolution, influencing everything from its chemical composition to its overall structure. As we continue our journey through the Whirlpool Galaxy, we'll see how these star-forming regions connect to other phenomena, creating a web of interactions that define this cosmic wonder. But for now, let's marvel at the incredible process of star birth, a reminder of the dynamic and ever-changing nature of the universe. Now, let's turn our attention to a fascinating cosmic dance happening right next to the Whirlpool Galaxy, its interaction with its smaller companion, NGC 5195. This smaller galaxy isn't just a passive neighbor, it's actively shaping the Whirlpool Galaxy in ways that are both dramatic and beautiful. The gravitational pull between these two galaxies has created a dynamic relationship that's impossible to ignore. As NGC 5195 orbits the Whirlpool Galaxy, its gravity tugs on the larger galaxy's spiral arms, distorting their shape and creating ripples of gas and dust. These ripples, in turn, compress the gas clouds within the Whirlpool Galaxy, triggering bursts of star formation. It's like a cosmic domino effect. One galaxy's movement sets off a chain reaction that lights up the other. This interaction isn't just a fleeting event, it's a process that has been unfolding over millions of years. The gravitational forces at play have stretched and twisted the Whirlpool Galaxy's spiral arms, giving them their iconic, slightly warped appearance. At the same time, the collision of gas clouds between the two galaxies has sparked the birth of countless new stars, adding to the Whirlpool's already vibrant star-forming regions. But the effects of this interaction go beyond just star formation. The gravitational tug-of-war has also created long, faint streams of stars and gas known as tidal tails that stretch out into space. These tails are like cosmic breadcrumbs, tracing the history of the galaxy's interactions and providing clues about their past and future. Astronomers study this interaction not just to understand the Whirlpool Galaxy, but to learn more about how galaxies evolve over time. The Whirlpool and its companion are a prime example of how galactic collisions and interactions can transform the structure and behavior of galaxies, shaping the universe as we know it. As we move forward, we'll see how this interaction ties into other phenomena within the Whirlpool Galaxy, creating a web of connections that make this galaxy so unique. But for now, let's appreciate the beauty and complexity of this cosmic partnership, a reminder that even in the vastness of space, no galaxy is an island. Now, let's shift our gaze to one of the most striking features of the Whirlpool Galaxy, its intricate cosmic dust lanes. These dark, winding ribbons of dust are not just beautiful to look at, they play a crucial role in the galaxy's ongoing story of creation and transformation. The dust lanes are composed of tiny particles primarily made up of carbon, silicates, and other heavy elements. These particles are incredibly fine, almost like cosmic soot, and they gather in dense clouds that snake through the galaxy's spiral arms. When we look at the Whirlpool Galaxy, these dust lanes appear as dark streaks against the bright backdrop of stars and glowing gas. But don't let their shadowy appearance fool you. These lanes are anything but empty. One of the most fascinating things about these dust lanes is how they interact with light. As starlight passes through them, the dust absorbs and scatters the light, particularly in the blue and ultraviolet parts of the spectrum. This is why the lanes appear so dark to us, but this process isn't just about blocking light, it's also about transforming it. The dust absorbs energy from the light and re-emits it as infrared radiation, which astronomers can detect to study the hidden structures within the galaxy. These dust lanes are far more than just cosmic roadblocks, they're also the birthplaces of new stars and planets. Within the dense clouds of dust, gravity begins to pull particles together, forming clumps that grow larger and denser over time. As these clumps collapse under their own weight, they heat up, eventually igniting nuclear fusion and giving birth to new stars. The leftover material from this process can then coalesce into planets, moons, and other celestial bodies. In a way, the dust lanes are like the galaxy's nurseries, providing the raw materials needed for star and planet formation. Without them, the Whirlpool Galaxy would lack the vibrant star-forming regions that make it so visually stunning. As we continue our journey through the Whirlpool Galaxy, we'll see how these dust lanes connect to other phenomena, creating a complex web of interactions that shape the galaxy's evolution. But for now, take a moment to marvel at these dark, mysterious pathways, silent witnesses to the ongoing cycle of creation in the cosmos. Now, let's turn our attention to another fascinating aspect of the Whirlpool Galaxy, the remnants of past supernovas scattered throughout its vast expanse. These cosmic echoes are more than just relics of explosive events. They are key to understanding the life cycles of stars and the chemical evolution of the galaxy itself. When a massive star reaches the end of its life, it doesn't fade quietly. Instead, it goes out with a bang, a supernova. This colossal explosion tears the star apart, flinging its outer layers into space at incredible speeds. What remains is a supernova remnant, a glowing shell of gas and dust that expands outward, carrying with it the heavy elements forged in the star's core. These remnants are like cosmic recycling centers. During the star's life, nuclear fusion in its core creates elements like carbon, oxygen, silicon, and even iron. When the star explodes, these elements are scattered across the galaxy, enriching the surrounding space with the building blocks of planets, moons, and even life itself. Without supernova, the universe would lack many of the heavy elements that make up everything from the ground beneath our feet to the stars above our heads. In the Whirlpool Galaxy, astronomers have identified several supernova remnants, each telling a unique story. Some are still expanding, their shock waves heating the surrounding gas and creating intricate structures that glow in X-rays and radio waves. Others have faded over time, blending into the galaxy's background but still contributing to its chemical makeup. Studying these remnants gives us a glimpse into the violent yet essential processes that shape galaxies. They help us understand how stars live, die, and ultimately give rise to new generations of stars and planets. In a way, supernova remnants are the galaxy's way of turning destruction into creation, ensuring that the cycle of stellar life continues. As we move forward, we'll see how these remnants connect to other phenomena in the Whirlpool Galaxy, weaving together a story of cosmic evolution that spans billions of years. But for now, take a moment to reflect on these powerful remnants, silent witnesses to the explosive ends of stars and the beginnings of something new. Now, let's shift our gaze to one of the most energetic and mysterious events in the universe: gamma-ray bursts. These fleeting yet incredibly powerful explosions are like cosmic fireworks, releasing more energy in a few seconds than our sun will emit in its entire lifetime. And yes, the Whirlpool Galaxy has been home to some of these extraordinary events. Gamma-ray bursts, or GRBs for short, are thought to originate from two main sources. The first occurs when a massive star collapses at the end of its life, forming a black hole. As the star's core implodes, it sends out jets of particles traveling at nearly the speed of light. These jets produce intense bursts of gamma rays, the most energetic form of light. The second type happens when two neutron stars, the dense remnants of dead stars, collide, creating a similar but equally spectacular explosion. In the Whirlpool Galaxy, these bursts are rare but incredibly significant. When a GRB occurs, it can outshine the entire galaxy for a brief moment, releasing energy that ripples through space. The impact of these bursts is profound. They can ionize gas in their path, stripping electrons from atoms and altering the chemistry of the surrounding regions. This process can even trigger new star formation by compressing nearby gas clouds, setting the stage for future stellar nurseries. Detecting gamma-ray bursts is no small feat. Because they last only a few seconds to a few minutes, astronomers rely on specialized satellites equipped with gamma-ray detectors. These instruments can pinpoint the location of a burst, allowing telescopes on Earth to quickly follow up and observe the aftermath. In the Whirlpool Galaxy, these observations have provided valuable insights into the conditions that lead to such extreme events. What makes gamma-ray bursts even more fascinating is their role as cosmic messengers. The light from these bursts travels billions of light years, carrying information about the early universe. By studying them, astronomers can learn about the formation of black holes, the behavior of matter under extreme conditions, and even the rate at which the universe is expanding. As we continue our journey through the Whirlpool Galaxy, these bursts remind us of the dynamic and ever-changing nature of the cosmos. They are fleeting, yet their impact echoes across space and time, shaping the galaxy in ways we are only beginning to understand. Next, we'll explore another enigmatic phenomenon: mysterious radio emissions that seem to defy explanation. Now, let's turn our attention to another cosmic mystery emanating from the Whirlpool Galaxy: mysterious radio emissions. These signals, invisible to the human eye, are detected as faint whispers across the vastness of space, and they have left astronomers scratching their heads. Unlike the explosive gamma-ray bursts we just explored, these radio emissions are more subtle, yet no less intriguing. Radio waves are a form of electromagnetic radiation, just like visible light, but they have much longer wavelengths. This makes them ideal for traveling great distances through space, often carrying information from the farthest reaches of the universe. In the Whirlpool Galaxy, these emissions are coming from regions that don't always align with what we'd expect. Some of the most puzzling signals seem to originate from areas where there are no obvious sources, like black holes or neutron stars. So, what could be causing these mysterious emissions? One leading theory points to the galaxy's supermassive black hole at its center. As matter spirals into the black hole, it heats up and emits radiation across the electromagnetic spectrum, including radio waves. However, the signals we're detecting don't always match the patterns expected from such activity. Another possibility involves neutron stars, the dense remnants of exploded stars. These objects can emit powerful beams of radio waves as they spin, creating what we call pulsars. Yet, even these don't fully explain the strange, irregular signals coming from the Whirlpool Galaxy. Adding to the mystery, some of these emissions appear to be transient, meaning they come and go without warning. This unpredictability makes them incredibly difficult to study. Astronomers have to constantly monitor the galaxy, hoping to catch these signals in action. When they do, the data often raises more questions than answers. For instance, some emissions seem to be coming from regions with no visible stars or other known sources of energy. Could there be something entirely new at play here? The implications of these unexplained radio emissions are profound. They could hint at unknown astrophysical processes or even entirely new types of celestial objects. Some scientists speculate that they might be linked to dark matter, the elusive substance that makes up a significant portion of the universe's mass but has never been directly observed. Others suggest they could be the result of interactions between cosmic rays and magnetic fields within the galaxy. What makes these signals so captivating is their potential to reveal secrets about the universe that we haven't even begun to imagine. Every time we detect one, it's like receiving a cryptic message from the cosmos, urging us to look deeper and question what we think we know. As we move forward in our exploration of the Whirlpool Galaxy, these mysterious radio emissions remind us that even in a galaxy as well studied as this one, there are still countless enigmas waiting to be unraveled. Next, we'll venture into the faint, glowing halo that surrounds the galaxy, a feature that holds its own set of secrets and surprises. Now, let's shift our gaze to the ethereal glow that surrounds the Whirlpool Galaxy, its faint, mysterious halo. This halo, a diffuse cloud of gas and stars, stretches far beyond the galaxy's bright spiral arms, creating a ghostly aura that hints at the galaxy's turbulent past and its ongoing evolution. The Whirlpool's halo is composed primarily of hydrogen gas, along with a scattering of older stars that were likely ejected from the galaxy's main disk during violent interactions with its companion galaxy, NGC 5195. These interactions, which we've touched on earlier, don't just distort the galaxy's shape, they also fling stars and gas into the outer reaches, creating this vast, glowing envelope. But the halo isn't just a byproduct of galactic collisions. It plays a crucial role in the galaxy's life cycle. The gas within the halo can eventually fall back into the galaxy, fueling new generations of star formation. This process, known as galactic recycling, ensures that the Whirlpool Galaxy continues to evolve and thrive over billions of years. Interestingly, the halo also contains traces of heavier elements like oxygen and carbon, which were forged in the hearts of ancient stars and then expelled into space through supernova explosions. These elements are essential for the formation of planets and, ultimately, life. So, in a way, the halo is not just a relic of the past, it's a reservoir of the building blocks for future cosmic wonders. Studying the Whirlpool's halo is no easy task. Its faint glow is often overshadowed by the galaxy's brighter features, making it difficult to observe. Astronomers rely on specialized instruments and techniques, such as ultraviolet and radio observations, to map its structure and composition. What they've discovered so far is that the halo is far from uniform. It contains clumps and streams of gas, as well as regions of higher density, which may hold clues to the galaxy's history of interactions and mergers. One of the most intriguing aspects of the halo is its connection to dark matter. While the halo itself is made of ordinary matter, it's believed to be embedded within a much larger, invisible halo of dark matter. This dark matter halo exerts a gravitational pull that helps hold the galaxy together and influences the motion of stars and gas within the halo. Understanding the relationship between the visible halo and its dark counterpart is key to unraveling the mysteries of galaxy formation and evolution. As we continue to explore the Whirlpool Galaxy, its halo serves as a reminder that even the faintest features can hold profound significance. This glowing envelope, often overlooked, is a testament to the galaxy's dynamic history and its ongoing transformation. Next, we'll dive into another fascinating aspect of the Whirlpool Galaxy, the mysterious clumps of dark matter that lurk within its structure, shaping its destiny in ways we're only beginning to understand. Now, let's turn our attention to one of the most enigmatic aspects of the Whirlpool Galaxy, the mysterious clumps of dark matter scattered throughout its structure. Dark matter, an invisible and elusive substance, makes up a significant portion of the universe's mass, yet it doesn't emit, absorb, or reflect light, making it incredibly difficult to detect directly. Despite its invisibility, dark matter's presence is felt through its gravitational effects, and the Whirlpool Galaxy is no exception. Within the whirlpool, dark matter clumps are believed to be distributed unevenly, creating a hidden framework that shapes the galaxy's rotation and overall structure. These clumps exert a gravitational pull on the visible matter, stars, gas, and dust, causing them to move in ways that can't be explained by the gravity of visible matter alone. For instance, stars on the outer edges of the galaxy rotate at speeds that would send them flying into space if not for the additional gravitational influence of dark matter. So, how do astronomers detect something they can't see? The answer lies in observing the behavior of visible objects. By studying the motion of stars and gas clouds, scientists can infer the presence and distribution of dark matter. One key method involves measuring the rotation curves of galaxies, which plot the speed of stars and gas at different distances from the galactic center. In the Whirlpool Galaxy, these curves reveal that stars far from the center move faster than expected, a telltale sign of dark matter's gravitational grip. Another technique involves gravitational lensing, where the gravity of a massive object, like a dark matter clump, bends the light from background objects. While this effect is more commonly observed in galaxy clusters, subtle distortions in the whirlpool structure hint at the presence of dark matter clumps within the galaxy itself. These clumps don't just influence the galaxy's rotation, they also play a role in its evolution. Dark matter acts as a cosmic scaffold, guiding the formation of galaxies and shaping their large-scale structure. In the whirlpool, dark matter clumps may have helped funnel gas into the galaxy's spiral arms, triggering bursts of star formation and contributing to its stunning appearance. Interestingly, the distribution of dark matter clumps isn't uniform. Some regions of the galaxy may contain denser concentrations, while others are relatively sparse. This uneven distribution could be a result of past interactions with the companion galaxy, NGC 5195, which may have stirred up the dark matter, creating ripples and clumps in its distribution. As we continue to study the Whirlpool Galaxy, dark matter remains one of its greatest mysteries. While we can't see it directly, its influence is undeniable, shaping the galaxy's structure, rotation, and even its future. Next, we'll explore another fascinating phenomenon, the theory of galactic cannibalism, and how the Whirlpool Galaxy may have grown by consuming smaller galaxies over time. Now, let's dive into a phenomenon that sounds almost like something out of a cosmic thriller: galactic cannibalism. This intriguing theory suggests that the Whirlpool Galaxy may have grown larger and more massive by consuming smaller galaxies over time. It's a process that's not as violent as it sounds, but it's no less fascinating. galactic cannibalism occurs when a larger galaxy, like the Whirlpool, gravitationally pulls in and merges with smaller neighboring galaxies. Over billions of years, these smaller galaxies are torn apart, their stars, gas, and dark matter absorbed into the larger galaxy. This process leaves behind subtle clues such as streams of stars or unusual star clusters, which astronomers can use to piece together the galaxy's history. In the case of the Whirlpool Galaxy, evidence of this cosmic feast can be found in its structure and the behavior of its stars. For example, astronomers have observed streams of stars flowing between the Whirlpool and its companion galaxy, NGC 5195. These streams are thought to be remnants of smaller galaxies that were disrupted and absorbed during close encounters. Additionally, the Whirlpool's outer regions contain star clusters that appear older and chemically different from those in the main body of the galaxy, hinting at an external origin. But why does this matter? Galactic cannibalism isn't just a dramatic cosmic event. It's a key driver of galaxy evolution. When a larger galaxy consumes a smaller one, it gains not only stars and gas but also dark matter. This influx of material can trigger new waves of star formation, alter the galaxy's shape, and even influence the growth of its central black hole. In the Whirlpool's case, these mergers may have contributed to the formation of its iconic spiral arms and the intense star-forming regions we see today. Interestingly, this process isn't unique to the Whirlpool Galaxy. Galactic cannibalism is thought to be a common occurrence in the universe, with even our own Milky Way showing signs of having absorbed smaller galaxies in the past. However, the Whirlpool's interactions with NGC 5195 provide a particularly clear example of how these mergers can shape a galaxy's structure and evolution. As we continue to study the Whirlpool Galaxy, the evidence of its cosmic appetite offers a glimpse into the dynamic and ever-changing nature of the universe. Next, we'll explore another captivating feature of this galaxy, its unusual star clusters, which hold secrets about its past and the processes that have shaped it over billions of years. Now, let's turn our attention to one of the most intriguing features of the Whirlpool Galaxy, its unusual star clusters. These clusters are not your average gatherings of stars. They hold secrets about the galaxy's past and offer clues about how it has evolved over billions of years. Star clusters are essentially groups of stars that are bound together by gravity, and they come in two main types: open clusters and globular clusters. Open clusters are younger, containing hundreds or thousands of stars, while globular clusters are much older and denser, often containing hundreds of thousands or even millions of stars. In the Whirlpool Galaxy, however, astronomers have discovered star clusters that don't quite fit into these traditional categories. Some of the star clusters in the Whirlpool are unusually large, with sizes that rival even the most massive globular clusters found in other galaxies. What's even more fascinating is their age. While many globular clusters in other galaxies are ancient, dating back to the early universe, some of the Whirlpool's clusters are relatively young, forming within the last few 100 million years. This suggests that the Whirlpool has been actively producing new star clusters, possibly as a result of its interactions with its companion galaxy, NGC 5195. Another striking feature of these clusters is their chemical composition. Unlike the metal-poor stars typically found in globular clusters, some of the Whirlpool's clusters contain stars with higher levels of heavy elements such as iron and oxygen. This indicates that these stars formed from gas that had already been enriched by previous generations of stars, a process that takes time and suggests a more complex history of star formation in the galaxy. These unusual star clusters also provide valuable insights into the Whirlpool's dynamic environment. The galaxy's spiral arms, with their dense gas and dust, create the perfect conditions for the birth of new star clusters. As these clusters age, some may be torn apart by the galaxy's gravitational forces, while others may survive and continue to evolve. This ongoing cycle of creation and destruction is a key part of what makes the Whirlpool Galaxy so unique. What's truly remarkable is how these clusters differ from those in other galaxies. For example, in the Milky Way, most globular clusters are ancient relics from the galaxy's early days. In contrast, the Whirlpool's clusters span a wide range of ages, offering a snapshot of star formation across different eras. This diversity makes the Whirlpool a living laboratory for studying how star clusters form, evolve, and interact with their surroundings. As we continue to explore the Whirlpool Galaxy, these unusual star clusters remind us of the galaxy's rich and complex history. They are not just collections of stars, they are windows into the processes that have shaped the galaxy over billions of years. Next, we'll delve into another fascinating aspect of the Whirlpool, its magnetic fields, which play a crucial role in shaping its structure and influencing star formation. Now, let's shift our focus to something invisible yet incredibly powerful: the magnetic fields of the Whirlpool Galaxy. These magnetic fields might not be something we can see directly, but their influence is felt across the galaxy, shaping its structure and even playing a role in the birth of new stars. Magnetic fields in galaxies are like invisible threads woven through space, guiding the movement of gas, dust, and charged particles. In the Whirlpool Galaxy, these fields are particularly strong and complex, stretching across its spiral arms and intertwining with its vast clouds of gas and dust. But how do astronomers even measure something as elusive as a magnetic field in a galaxy millions of light years away? The answer lies in a phenomenon called synchrotron radiation. When charged particles, like electrons, spiral around magnetic field lines, they emit this type of radiation, which can be detected by radio telescopes. By studying the polarization of this radiation, essentially the direction in which the light waves vibrate, scientists can map out the structure and strength of the galaxy's magnetic fields. It's a bit like using a compass to trace the invisible lines of force, but on a cosmic scale. These magnetic fields do more than just exist, they actively shape the galaxy. For instance, they help channel gas and dust into the spiral arms, where conditions are ripe for star formation. Without these fields, the gas might spread out more evenly, making it harder for stars to form in such concentrated regions. The fields also play a role in stabilizing the galaxy's structure, preventing it from collapsing or flying apart under the influence of gravity and other forces. One of the most fascinating aspects of the Whirlpool's magnetic fields is their connection to star formation. As gas clouds collapse under gravity to form new stars, the magnetic fields can either help or hinder the process. On one hand, they can slow down the collapse by exerting pressure on the gas. On the other hand, they can also help channel material into denser regions, creating the perfect conditions for stars to ignite. This delicate balance between magnetic forces and gravity is a key factor in how stars are born in the Whirlpool Galaxy. Interestingly, the magnetic fields in the Whirlpool are not uniform. They vary in strength and direction across different parts of the galaxy, reflecting the complex interplay of forces at work. For example, near the galaxy's center, where the supermassive black hole resides, the fields are particularly intense, likely influenced by the black hole's powerful gravitational pull and the jets of particles it ejects. In contrast, the fields in the outer regions of the spiral arms are weaker, but still play a crucial role in shaping the galaxy's overall structure. Studying these magnetic fields gives us a deeper understanding of how galaxies evolve over time. They are not just passive features, they are dynamic forces that influence everything from the formation of stars to the movement of gas and dust. In the Whirlpool Galaxy, these fields are a testament to the intricate and interconnected nature of cosmic processes. As we continue to unravel the mysteries of the Whirlpool, its magnetic fields remind us that even the unseen forces of the universe have a profound impact on the cosmos. Next, we'll explore another enigmatic feature of this galaxy: the mysterious X-ray glow that emanates from its depths, offering yet another clue to its hidden workings. Now, let's turn our attention to a phenomenon that radiates with mystery: the X-ray glow of the Whirlpool Galaxy. This faint but persistent glow, detected by powerful X-ray telescopes, offers a glimpse into some of the most energetic processes taking place within the galaxy. But what exactly is causing this glow, and why does it continue to puzzle astronomers? The X-ray glow of the Whirlpool Galaxy is thought to originate from several possible sources, each more fascinating than the last. One of the primary suspects is the supermassive black hole at the galaxy's center. As matter spirals into the black hole, it heats up to incredibly high temperatures, emitting X-rays in the process. These emissions can be detected across vast distances, providing a window into the extreme conditions near the black hole. Another potential source of the X-ray glow is hot gas scattered throughout the galaxy. When stars explode as supernova, they release enormous amounts of energy, heating the surrounding gas to millions of degrees. This superheated gas then emits X-rays, contributing to the overall glow. In the Whirlpool Galaxy, regions of intense star formation, particularly in its spiral arms, are likely hotspots for this kind of activity, but the mystery doesn't end there. Some of the X-ray emissions may also come from binary star systems, where a neutron star or black hole pulls material from a companion star. As this material falls onto the dense object, it heats up and emits X-rays. These systems, known as X-ray binaries, are scattered throughout the galaxy and add to the complex tapestry of X-ray sources. What makes the Whirlpool's X-ray glow particularly intriguing is that it doesn't come from a single source but rather a combination of many. This makes it challenging for astronomers to pinpoint exactly where the emissions are coming from and what processes are driving them. The glow is like a cosmic puzzle, with each piece representing a different source or mechanism. Studying this X-ray glow is crucial because it reveals aspects of the galaxy that are invisible in other wavelengths of light. For example, X-rays can penetrate dense clouds of gas and dust, allowing astronomers to peer into regions that would otherwise remain hidden. This makes X-ray observations an essential tool for understanding the inner workings of the Whirlpool Galaxy. Despite decades of research, the X-ray glow of the Whirlpool Galaxy remains a topic of active investigation. New observations and advanced telescopes continue to shed light on its origins, but many questions still linger. What role do black holes play in producing this glow? How much of it comes from hot gas versus binary systems? And what can these emissions tell us about the galaxy's history and evolution? As we delve deeper into the mysteries of the Whirlpool, its X-ray glow serves as a reminder of the galaxy's dynamic and ever-changing nature. Next, we'll explore another captivating feature: the infrared glow that reveals hidden star-forming regions and dust clouds, offering yet another layer of insight into this cosmic wonder. Now, shifting our gaze to a different kind of light, let's explore the Whirlpool Galaxy's infrared glow, a phenomenon that unveils secrets hidden from the naked eye. Unlike visible light, infrared radiation can penetrate thick clouds of cosmic dust, allowing us to peer into regions of the galaxy that would otherwise remain shrouded in mystery. This glow is like a cosmic flashlight, illuminating the hidden corners of the Whirlpool and revealing its most active star-forming regions. The infrared glow of the Whirlpool Galaxy is primarily emitted by dust particles heated by nearby stars. As young, massive stars form, they radiate intense energy, warming the surrounding dust clouds. These clouds, in turn, emit infrared light, which can be detected by specialized telescopes like the Spitzer Space Telescope. This process gives astronomers a unique view of the galaxy's stellar nurseries, places where new stars are born, and where the raw materials of the universe are being shaped into future suns and planets. One of the most striking features revealed by infrared observations is the intricate network of dust lanes weaving through the galaxy's spiral arms. These lanes, often invisible in other wavelengths, are dense with gas and dust, providing the perfect environment for star formation. Infrared light allows us to map these regions in detail, showing how they connect and interact with the galaxy's overall structure. But the infrared glow doesn't just highlight star-forming regions, it also reveals the presence of older stars. Cooler, aging stars emit more infrared light than their younger, hotter counterparts, making them easier to detect in this wavelength. By studying the infrared glow, astronomers can piece together the life cycles of stars within the whirlpool, from their fiery births to their quiet, glowing declines. Another fascinating aspect of the whirlpool's infrared emissions is their ability to trace the galaxy's history. The distribution of dust and gas, as seen in infrared light, provides clues about past interactions with its companion galaxy, NGC 5195. These interactions likely triggered waves of star formation, leaving behind a trail of infrared bright regions that tell the story of the galaxy's evolution. Infrared observations also help us understand the role of dust in shaping the galaxy's appearance. Dust not only obscures visible light but also plays a crucial role in the formation of stars and planets. By studying the infrared glow, scientists can measure the amount and distribution of dust, shedding light on how it influences the galaxy's structure and dynamics. The whirlpool's infrared glow is more than just a beautiful cosmic phenomenon, it's a vital tool for astronomers. It allows us to see beyond the visible, uncovering the hidden processes that drive the galaxy's evolution. From star-forming regions to ancient stellar remnants, the infrared glow paints a vivid picture of the whirlpool's inner workings. As we continue our journey through the Whirlpool Galaxy, the next phenomenon we'll explore is the ultraviolet light emitted by its youngest, hottest stars. A dazzling display that helps us map the galaxy's most active regions and understand the life cycles of its stellar inhabitants. Now, let's turn our attention to the dazzling ultraviolet light that radiates from the Whirlpool Galaxy, a phenomenon that shines a spotlight on its youngest and most energetic stars. Unlike the infrared glow we just explored, ultraviolet light is emitted by stars that are incredibly hot and massive, often in the early stages of their lives. This light acts as a cosmic beacon, guiding astronomers to the galaxy's most active star-forming regions and offering a glimpse into the fiery beginnings of stellar evolution. The ultraviolet light from the Whirlpool Galaxy is primarily produced by young, massive stars which burn brightly and intensely. These stars, often just a few million years old, are so hot that they emit most of their energy in the ultraviolet part of the spectrum. By observing this light, astronomers can pinpoint exactly where new stars are being born, as these regions glow brightly in ultraviolet wavelengths. It's like having a cosmic map that highlights the galaxy's most vibrant neighborhoods. One of the key tools used to study this ultraviolet light is the Hubble Space Telescope, which has captured stunning images of the Whirlpool Galaxy in this wavelength. These images reveal intricate details of the galaxy's spiral arms, where clusters of young stars are densely packed. The ultraviolet light not only shows where these stars are located, but also helps scientists measure their temperatures, sizes, and ages. This information is crucial for understanding how stars form and evolve over time, but the story doesn't end there. Ultraviolet light also plays a vital role in shaping the galaxy itself. The intense radiation from young stars can heat up and ionize the surrounding gas, creating vast bubbles of hot plasma. These bubbles can push against the cooler gas and dust, triggering further star formation in a chain reaction that ripples through the galaxy. In this way, ultraviolet light is not just a passive observer, it's an active participant in the whirlpool's ongoing evolution. Another fascinating aspect of the whirlpool's ultraviolet emissions is their ability to reveal the galaxy's history. By studying the distribution of young stars, astronomers can piece together the timeline of star formation events, tracing how the galaxy has grown and changed over billions of years. This information provides valuable insights into the processes that drive galactic evolution, from the birth of stars to the formation of complex structures like spiral arms. Ultraviolet light also helps us understand the life cycles of stars. While young, massive stars dominate the ultraviolet glow, older stars emit much less of this light. By comparing the ultraviolet emissions of different regions, astronomers can track how stars age and how their energy output changes over time. This allows them to build a comprehensive picture of stellar evolution, from the fiery birth of a star to its eventual decline. The Whirlpool's ultraviolet light is more than just a stunning visual phenomenon. It's a powerful tool for unraveling the mysteries of star formation and galactic evolution. By studying this light, astronomers can explore the galaxy's most active regions, trace its history, and gain a deeper understanding of the processes that shape the universe. As we continue our journey through the Whirlpool Galaxy, the next phenomenon we'll explore is the high-energy cosmic rays that originate from its depths, a mysterious and powerful force that adds another layer of intrigue to this cosmic wonder. Now let's shift our focus to a phenomenon that packs an extraordinary punch: the high-energy cosmic rays streaming from the depths of the Whirlpool Galaxy. These cosmic rays are not rays in the traditional sense, but rather highly charged particles racing through space at nearly the speed of light. They are among the most energetic particles in the universe, and their origins and journeys are as mysterious as they are fascinating. Cosmic rays are primarily composed of protons, electrons, and atomic nuclei stripped of their electrons. These particles are accelerated to incredible speeds by some of the most extreme environments in the galaxy, such as supernova explosions, black holes, and even the turbulent regions around young, massive stars. When these events occur, they unleash shockwaves that propel particles to energies far beyond what any human-made particle accelerator could achieve. One of the most intriguing sources of cosmic rays in the Whirlpool Galaxy is its supermassive black hole. As matter spirals into the black hole, it generates intense magnetic fields and powerful jets of particles. These jets can accelerate particles to near light speeds, sending them hurtling across the galaxy and beyond. Supernova remnants are another key source. When a massive star explodes, the shock waves from the blast can accelerate particles to cosmic ray energies, creating a cascade of high-energy particles that ripple through space. But how do these cosmic rays travel through the vast expanse of the galaxy? Unlike light, which travels in straight lines, cosmic rays are influenced by magnetic fields. As they move through the galaxy, they spiral along the lines of these magnetic fields, zigzagging their way through space. This makes their paths unpredictable and difficult to trace back to their exact origins. However, by studying the direction and energy of these particles, astronomers can piece together clues about where they came from and what processes accelerated them. The Whirlpool Galaxy's cosmic rays also play a significant role in shaping its environment. When these high-energy particles collide with gas and dust, they can trigger a chain reaction of particle interactions, producing secondary particles and even gamma rays. These interactions contribute to the galaxy's overall energy balance and can influence the formation of new stars and planets. In a way, cosmic rays are like cosmic messengers, carrying information about the most violent and energetic events in the galaxy. Studying cosmic rays is no easy task because they are charged particles. They are deflected by magnetic fields, making it challenging to pinpoint their exact sources. However, astronomers use a combination of ground-based observatories and space telescopes to detect these particles and analyze their properties. By understanding cosmic rays, scientists can gain insights into the most extreme processes in the universe, from the explosive deaths of stars to the powerful jets of black holes. The Whirlpool Galaxy's cosmic rays are a testament to the dynamic and energetic nature of this cosmic wonder. They remind us that even in the vastness of space, particles can travel incredible distances, carrying with them the stories of the galaxy's most dramatic events. As we continue to unravel the mysteries of these high-energy particles, we gain a deeper appreciation for the forces that shape the universe. Next, we'll explore the long, faint tidal tails created by the Whirlpool Galaxy's interaction with its companion, NGC 5195, a phenomenon that reveals the dramatic effects of galactic collisions. Now, let's turn our attention to a striking feature of the Whirlpool Galaxy, its long, faint tidal tails. These delicate streams of stars and gas stretch far beyond the galaxy's main body, serving as a cosmic fingerprint of its dramatic interaction with its smaller companion, NGC 5195. These tidal tails are not just beautiful to observe, they hold vital clues about the forces at play during galactic collisions and the evolution of galaxies over time. Tidal tails form when two galaxies pass close to each other, their gravitational forces pulling and stretching material from one another. In the case of the Whirlpool Galaxy, its interaction with NGC 5195 has created these sweeping arcs of stars and gas. As the galaxies graze past each other, the immense gravitational pull tugs on the outer regions of both galaxies, flinging stars and gas into long, curved streams. These tails can extend for tens of thousands of light-years, far beyond the visible boundaries of the galaxies themselves. What makes tidal tails so fascinating is that they are not random. They follow precise patterns dictated by the gravitational dance between the two galaxies. The material in these tails is often stripped from the outer edges of the galaxies, where gravitational forces are weaker. Over time, these streams can become twisted and distorted as the galaxies continue to interact, creating intricate structures that astronomers can study to understand the history of the collision. The tidal tails of the Whirlpool Galaxy also reveal the immense scale of galactic interactions. They show us that even though galaxies may appear serene and unchanging from a distance, they are constantly evolving, shaped by the gravitational forces of their neighbors. These tails are like cosmic breadcrumbs, tracing the path of the galaxy's past encounters and hinting at their future trajectories. Studying tidal tails provides astronomers with a unique opportunity to understand the dynamics of galactic collisions. By analyzing the composition and motion of the material in these tails, scientists can reconstruct the sequence of events that led to their formation. For example, the presence of young stars in the tails suggests that the gravitational interaction triggered bursts of star formation, while older stars reveal the long-term effects of the collision. The Whirlpool Galaxy's tidal tails are a vivid reminder of the interconnectedness of the universe. They show us that galaxies are not isolated islands but part of a vast cosmic web, constantly influencing and reshaping one another. As we continue to study these features, we gain a deeper understanding of how galaxies grow, evolve, and interact over billions of years. Next, we'll explore the slight warping of the Whirlpool Galaxy's disk, a subtle yet fascinating effect caused by its gravitational interactions with NGC 5195. This phenomenon offers even more insights into the dynamic nature of galactic encounters. Now, let's shift our focus to another intriguing feature of the Whirlpool Galaxy, the slight warping of its disk. This subtle distortion, though not immediately obvious, is a direct result of the galaxy's ongoing gravitational dance with its companion, NGC 5195. The warped disk is a fascinating phenomenon that reveals how even the smallest interactions can have profound effects on a galaxy's structure and behavior. Galactic disks are typically flat and symmetrical, but the Whirlpool Galaxy's disk shows a noticeable bend, particularly at its outer edges. This warping occurs when the gravitational forces from a nearby galaxy, in this case NGC 5195, pull and twist the disk out of its original plane. Imagine gently bending a vinyl record. The disk remains intact, but its shape is no longer perfectly flat. Similarly, the Whirlpool Galaxy's disk has been subtly reshaped by the gravitational tug of its companion. This warping isn't just a visual curiosity, it has significant implications for the galaxy's dynamics. The distortion affects the distribution of stars, gas, and dust within the disk, altering the way these materials move and interact. For instance, the warped regions may experience changes in gravitational stability, which can influence the formation of new stars or the behavior of existing ones. Over time, these effects can ripple through the galaxy, reshaping its overall structure and evolution. One of the most interesting aspects of the Whirlpool Galaxy's warped disk is how it serves as a cosmic record of past interactions. By studying the degree and pattern of the warping, astronomers can piece together the history of the galaxy's encounters with NGC 5195. The warped disk acts like a time capsule, preserving the gravitational forces that have shaped the galaxy over millions of years. Moreover, the warping provides valuable insights into the nature of dark matter. The gravitational forces responsible for the distortion are not just from the visible matter in NGC 5195, but also from the dark matter surrounding both galaxies. By analyzing the warped disk, scientists can better understand how dark matter influences galactic interactions and contributes to the overall structure of the universe. The Whirlpool Galaxy's warped disk is a testament to the dynamic and ever-changing nature of the cosmos. It reminds us that even the most massive structures in the universe are not static, but are constantly being reshaped by the forces around them. As we continue to study this phenomenon, we gain a deeper appreciation for the intricate interplay of gravity, matter, and time that governs the evolution of galaxies. Next, we'll explore the streams of stars flowing between the Whirlpool Galaxy and its companion, a phenomenon that further highlights the interconnectedness of these cosmic neighbors. Now, let's turn our attention to a breathtaking feature of the Whirlpool Galaxy: the streams of stars that flow between it and its companion, NGC 5195. These star streams are like cosmic rivers, weaving through the vast expanse of space and connecting the two galaxies in a delicate gravitational embrace. They are a stunning reminder of the intricate relationships that exist between celestial neighbors. These streams form as a result of the intense gravitational forces exerted by the Whirlpool Galaxy and NGC 5195 during their close encounters. As the two galaxies pass by each other, their gravitational pull tugs on stars, gas, and dust, stretching them out into long, flowing trails. Picture a cosmic tug-of-war where the stars are caught in the middle, pulled in opposite directions until they form these beautiful, elongated streams. What makes these star streams so fascinating is the story they tell about galactic interactions. Each stream is like a fingerprint, revealing the history of the gravitational dance between the Whirlpool Galaxy and its companion. By studying the shape, density, and movement of these streams, astronomers can reconstruct the timeline of their encounters. For example, the direction and curvature of the streams can indicate how close the galaxies came to each other and how their gravitational forces influenced one another over time. These streams also provide clues about the distribution of dark matter in and around the galaxies. Dark matter, though invisible, exerts a gravitational pull that affects the motion of stars and gas. By analyzing how the star streams bend and flow, scientists can map the unseen dark matter that shapes their paths. This helps us better understand the role dark matter plays in galactic interactions and the evolution of the universe as a whole. Another intriguing aspect of these star streams is their role in the ongoing evolution of the Whirlpool Galaxy. As stars from the streams are pulled into the galaxy, they contribute to its growth and transformation. This process, known as galactic cannibalism, is a key driver of how galaxies change over billions of years. The streams act as a bridge, transferring material from one galaxy to another and fueling new cycles of star formation and cosmic activity. The star streams between the Whirlpool Galaxy and NGC 5195 are not just a visual spectacle. They are a window into the dynamic and interconnected nature of the universe. They remind us that galaxies are not isolated islands in space but are constantly interacting, exchanging material, and reshaping each other through the forces of gravity. As we continue our journey through the mysteries of the Whirlpool Galaxy, we'll next explore the dense molecular clouds that serve as the birthplaces of new stars, uncovering how these cosmic nurseries contribute to the galaxy's vibrant and ever-changing landscape. Now, let's shift our gaze to one of the most vital and fascinating features of the Whirlpool Galaxy, its dense molecular clouds. These vast, swirling regions of gas and dust are the cosmic cradles where new stars are born, making them essential to the galaxy's vibrant and ever-evolving structure. Imagine these clouds as the raw materials of the universe, the building blocks from which stars and planetary systems emerge. Molecular clouds are composed primarily of hydrogen molecules, along with traces of other elements like carbon, oxygen, and nitrogen. These clouds are incredibly cold, with temperatures often dropping to just a few degrees above absolute zero. This frigid environment allows the gas to clump together under the influence of gravity, eventually collapsing to form the seeds of new stars. It's within these dense, dark regions that the magic of star formation begins. Astronomers study these molecular clouds using a variety of tools and techniques, particularly in the infrared and radio wavelengths. Infrared observations are especially valuable because they can penetrate the thick dust that often obscures these regions in visible light. By analyzing the light emitted by molecules like carbon monoxide, scientists can map the structure and density of these clouds, revealing their intricate shapes and the processes at work within them. One of the most remarkable aspects of these clouds is their sheer size. Some molecular clouds in the Whirlpool Galaxy span hundreds of light years, containing enough material to form thousands of stars. Within these clouds, smaller pockets of gas and dust, known as clumps, collapse further under their own gravity, eventually igniting nuclear fusion and giving birth to new stars. These clumps are often surrounded by swirling disks of material, which can later coalesce into planets, moons, and other celestial bodies. The role of molecular clouds in star formation is not just a one-time event. It's an ongoing process that shapes the galaxy over billions of years. As stars form within these clouds, they release energy and radiation, which can trigger further star formation in nearby regions. This creates a ripple effect, with waves of star birth spreading through the galaxy like cosmic fireworks. Studying these clouds also provides insights into the conditions necessary for star formation. By comparing molecular clouds in the Whirlpool Galaxy to those in other galaxies, astronomers can identify patterns and variations that help explain why some galaxies are more active in star formation than others. This research is crucial for understanding the life cycles of galaxies and the forces that drive their evolution. As we continue to unravel the mysteries of the Whirlpool Galaxy, these molecular clouds stand as a testament to the dynamic and creative forces at work in the universe. They remind us that even in the coldest, darkest corners of space, the seeds of new worlds are being sown, waiting to burst into light and life. Next, we'll explore the stellar nurseries within the Whirlpool Galaxy, where these newborn stars begin their journey, illuminating the galaxy with their brilliance and energy. Now, let's step into the heart of the Whirlpool Galaxy's most vibrant and energetic regions, the stellar nurseries. These are the cosmic cradles where the galaxy's youngest stars come to life, illuminating the darkness with their fiery brilliance. Stellar nurseries are not just random patches of space. They are carefully orchestrated environments where the perfect conditions for star formation come together. To understand how these nurseries work, we need to look at the ingredients required for star birth. First, there's the raw material, vast amounts of gas, primarily hydrogen and dust. These materials are found in abundance within the dense molecular clouds we discussed earlier, but gas and dust alone aren't enough. The second critical ingredient is gravity. Over time, gravity pulls these materials together, causing them to clump and collapse under their own weight. As the clumps grow denser, they heat up, eventually reaching temperatures high enough to ignite nuclear fusion. And just like that, a star is born. But stellar nurseries aren't just about the birth of stars, they're also about the environments that nurture them. These regions are often turbulent, with shock waves from nearby supernova or the gravitational pull of passing stars triggering further collapses. This creates a chain reaction where one star's birth can spark the formation of many more. It's a cosmic domino effect, turning these nurseries into bustling hubs of activity. Astronomers identify these nurseries by looking for specific signatures in the light they emit. Young stars, still surrounded by their birth clouds, often glow brightly in infrared light. This is because the thick dust that shrouds them absorbs visible light but re-emits it at longer infrared wavelengths. By using infrared telescopes, scientists can peer through the dust and observe these newborn stars in their earliest stages. Additionally, the presence of certain molecules like carbon monoxide helps map out the structure of these nurseries, revealing their intricate shapes and the processes at work within them. One of the most fascinating aspects of stellar nurseries is their diversity. Some are compact and intense, producing massive stars that burn brightly but briefly. Others are more spread out, giving rise to smaller, longer-lived stars like our Sun. This variety tells us that star formation isn't a one-size-fits-all process. Instead, it's shaped by the unique conditions of each nursery, from the density of the gas to the strength of the gravitational forces at play. As we explore these nurseries, we're not just witnessing the birth of stars, we're glimpsing the future of the Whirlpool Galaxy itself. The stars born here will go on to shape the galaxy's structure, its chemistry, and even its potential for hosting life. They are the building blocks of cosmic evolution, and their stories are written in the light they emit and the worlds they may one day create. Next, we'll turn our attention to the beautiful planetary nebulae scattered throughout the Whirlpool Galaxy, where aging stars leave behind stunning remnants of their final act. Now, let's shift our gaze to one of the most breathtaking sights in the Whirlpool Galaxy, the planetary nebulae. These glowing, colorful clouds are not just cosmic eye candy, they are the final acts of stars that have reached the end of their lives. When a star like our Sun exhausts its nuclear fuel, it doesn't simply fade away. Instead, it undergoes a dramatic transformation, shedding its outer layers into space and leaving behind a glowing shell of gas and dust. This is the birth of a planetary nebula. The process begins when a star enters its red giant phase, swelling to enormous sizes as it burns the last of its fuel. During this stage, the star's outer layers become unstable, and powerful stellar winds begin to blow them away. Over thousands of years, these layers expand outward, forming a glowing shell around the dying star. At the center of the nebula, the star's core remains, now a hot, dense remnant called a white dwarf. This white dwarf emits intense ultraviolet radiation, which lights up the surrounding gas, creating the vibrant colors we see in planetary nebulae. What makes planetary nebulae so fascinating is their incredible diversity. Some appear as delicate, symmetrical rings, while others take on more chaotic, irregular shapes. This variety is a result of the complex interactions between the star's winds, its magnetic fields, and the surrounding interstellar medium. For example, if the star has a companion, its gravitational pull can distort the nebula, creating intricate patterns and structures. These nebulae are like cosmic fingerprints, each one unique and telling a different story about the star that created it. But planetary nebulae are more than just beautiful. They are also crucial to understanding the life cycles of stars. As the outer layers of a star are ejected into space, they carry with them heavy elements like carbon, nitrogen, and oxygen. These elements, forged in the star's core during its lifetime, are scattered into the galaxy, enriching the interstellar medium. Over time, this material becomes part of new stars, planets, and even life itself. In this way, planetary nebulae are not just the end of one story, but the beginning of many others. Astronomers study planetary nebulae to learn about the final stages of stellar evolution and the chemical makeup of galaxies. By analyzing the light emitted by these nebulae, scientists can determine their composition, temperature, and even the speed at which they are expanding. This information helps us piece together the history of stars and the processes that shape galaxies like the Whirlpool. As we marvel at the beauty of these cosmic clouds, we're reminded of the interconnectedness of the universe. The death of one star gives rise to the birth of countless others, weaving a tapestry of creation and destruction that spans billions of years. Next, we'll journey to the ancient globular clusters orbiting the Whirlpool Galaxy, where some of the oldest stars in the universe reside, holding secrets of the galaxy's earliest days. Now, let's turn our attention to the ancient globular clusters that orbit the Whirlpool Galaxy, like cosmic time capsules holding secrets of the universe's earliest days. These dense, spherical collections of stars are some of the oldest structures in the galaxy, with ages often exceeding 10 billion years. To put that into perspective, these clusters were already ancient when our own solar system was just beginning to form. Globular clusters are fascinating because they contain hundreds of thousands, sometimes even millions, of stars packed tightly together in a relatively small space. This density creates a unique environment where stars interact gravitationally, sometimes even colliding or merging. Despite their crowded conditions, these clusters have remained remarkably stable over billions of years, making them invaluable tools for studying the history of galaxies. One of the most intriguing aspects of globular clusters is their composition. Unlike the younger stars found in the Whirlpool's spiral arms, the stars in these clusters are typically metal-poor. This means they contain fewer heavy elements like iron and carbon, which were rare in the early universe. By studying these stars, astronomers can piece together what the Whirlpool Galaxy was like in its infancy, when it was still forming and evolving. The distribution of globular clusters around the Whirlpool Galaxy also provides clues about its past. These clusters are not randomly scattered. Instead, they tend to orbit in a halo around the galaxy's central bulge. This pattern suggests that many of these clusters were formed during the galaxy's earliest stages, possibly even before its iconic spiral arms took shape. Some clusters may even be remnants of smaller galaxies that were absorbed by the Whirlpool long ago, a process known as galactic cannibalism. Astronomers use globular clusters to map the Whirlpool Galaxy's history in incredible detail. By measuring the ages, compositions, and motions of these clusters, scientists can reconstruct how the galaxy grew and changed over billions of years. For example, the presence of younger globular clusters in certain regions might indicate areas where the galaxy experienced bursts of star formation or mergers with other galaxies. These ancient star clusters are more than just relics of the past. They are active participants in the galaxy's ongoing story. Some globular clusters are still forming new stars, while others are home to exotic objects like black holes and neutron stars. Their resilience and longevity make them a testament to the enduring nature of the cosmos. As we explore these clusters, we're reminded that the Whirlpool Galaxy is not just a static image in the night sky, but a dynamic, evolving system with a rich and complex history. Next, we'll venture into the dark nebulae of the Whirlpool, where mysterious clouds of dust and gas obscure the light of distant stars, creating some of the galaxy's most enigmatic features. Now, let's shift our gaze to the shadowy regions of the Whirlpool Galaxy, where dark nebulae weave intricate patterns across the cosmic canvas. These mysterious clouds of dust and gas are not just voids in space. They are dense, opaque structures that absorb and scatter the light from stars behind them, creating striking silhouettes against the galaxy's glowing backdrop. Dark nebulae are composed primarily of tiny particles of dust and molecules of gas, such as hydrogen and carbon monoxide. These particles are incredibly fine, often no larger than a fraction of a millimeter, but they accumulate in vast quantities, forming dense clouds that can stretch for hundreds of light years. Despite their seemingly empty appearance, these nebulae are far from lifeless. In fact, they are often the birthplaces of new stars, as the dust and gas within them collapse under gravity to form stellar nurseries. One of the most fascinating aspects of dark nebulae is their role in shaping the Whirlpool Galaxy's visual identity. When viewed from Earth, these clouds create dramatic contrasts, blocking the light from background stars and highlighting the galaxy's intricate structure. They appear as dark, twisting lanes that snake through the spiral arms, adding depth and texture to the whirlpool's already stunning appearance. Without these nebulae, the galaxy would look far less dynamic, losing much of its visual complexity. But dark nebulae are more than just cosmic scenery. They play a crucial role in the galaxy's life cycle. The dust within these clouds absorbs ultraviolet light from nearby stars, cooling the surrounding gas and allowing it to condense into denser clumps. Over time, these clumps can collapse under their own gravity, igniting the process of star formation. In this way, dark nebulae are not just obstacles to light. They are also cradles of creation where the next generation of stars begins to shine. Interestingly, the dust in dark nebulae also serves as a cosmic recycling system. When massive stars die in supernova explosions, they release heavy elements like carbon, silicon, and iron into space. These elements become part of the dust grains in dark nebulae, which eventually become incorporated into new stars, planets, and even life itself. This cycle of destruction and rebirth is a fundamental part of the galaxy's evolution, and dark nebulae are at the heart of it. As we peer into these shadowy regions, we're reminded that even the darkest corners of the universe hold secrets waiting to be uncovered. Next, we'll explore the powerful cosmic jets that erupt from the Whirlpool Galaxy's central black hole, revealing yet another layer of its dynamic and ever-changing nature. Now, let's turn our attention to one of the most dramatic and energetic features of the Whirlpool Galaxy, its cosmic jets. These powerful streams of particles erupt from the galaxy's central supermassive black hole, shooting out into space at nearly the speed of light. These jets are not just spectacular to observe, they play a crucial role in shaping the galaxy's environment and influencing its evolution. The formation of these jets begins with the supermassive black hole at the heart of the Whirlpool Galaxy. As matter spirals into the black hole, it forms a swirling disk of gas and dust known as an accretion disk. Not all of this material is consumed by the black hole, though. Some of it is funneled along magnetic field lines and ejected outward in two narrow, high-speed jets perpendicular to the disk. These jets are composed of charged particles such as electrons and protons, and they carry immense amounts of energy. What makes these jets so fascinating is their sheer scale and power. They can extend for thousands of light years, far beyond the boundaries of the galaxy itself. As they travel through space, they collide with surrounding gas and dust, heating it up and creating shock waves that ripple through the interstellar medium. These interactions can trigger star formation in some regions while disrupting it in others, making the jets a double-edged sword in the galaxy's life cycle. The impact of these cosmic jets isn't limited to the Whirlpool Galaxy alone. They can influence the surrounding intergalactic space, redistributing energy and matter across vast distances. In some cases, jets from active galaxies like the Whirlpool can even affect neighboring galaxies, altering their structure and star formation rates. This makes them a key player in the larger cosmic ecosystem, connecting galaxies in ways we're only beginning to understand. Interestingly, the jets also serve as a kind of cosmic laboratory, allowing astronomers to study the extreme physics at work near black holes. By observing the jet's behavior, scientists can learn more about the properties of the black hole itself, such as its spin and the strength of its magnetic fields. These observations provide valuable insights into the nature of black holes and the processes that drive their activity. As we marvel at the Whirlpool's cosmic jets, we're reminded of the incredible forces at play in the universe. These jets are not just a byproduct of the galaxy's central black hole. They are a testament to the dynamic and interconnected nature of cosmic phenomena. Next, we'll explore the faint gamma-ray halo that surrounds the Whirlpool Galaxy, adding yet another layer of mystery to this already fascinating cosmic wonder. Now, let's shift our focus to a more elusive and mysterious feature of the Whirlpool Galaxy, its faint gamma-ray halo. This nearly invisible glow surrounds the galaxy, stretching far beyond its visible boundaries, and it's one of the most challenging phenomena to study in the cosmos. Gamma rays are the most energetic form of light, and detecting them requires highly specialized instruments, which is why this halo has remained a puzzle for astronomers. The origins of this gamma-ray halo are still not fully understood, but scientists believe it may be linked to the galaxy's supermassive black hole and its cosmic jets. As particles are ejected from the jets at incredible speeds, they interact with the surrounding gas and magnetic fields, producing gamma rays in the process. Another possibility is that the halo is created by cosmic rays, high-energy particles that travel through space, colliding with gas and dust in the galaxy's outer regions. These collisions can generate gamma rays, contributing to the faint glow that surrounds the whirlpool. What makes this halo particularly difficult to detect is its faintness and the interference from other sources of gamma rays in the universe. Gamma rays are often produced by violent events like supernova, neutron stars, and even distant galaxies, making it hard to isolate the specific signal from the whirlpool's halo. Additionally, gamma rays are absorbed by Earth's atmosphere, so they can only be observed using space-based telescopes like the Fermi Gamma Ray Space Telescope. Even with these advanced tools, the halo's faint signal is often buried in the noise of other cosmic gamma-ray sources. Despite these challenges, studying the gamma-ray halo provides valuable insights into the Whirlpool Galaxy's environment. It helps astronomers understand how energy and particles are distributed throughout the galaxy and its surroundings. The halo also offers clues about the processes that shape the galaxy's evolution, from the activity of its central black hole to the interactions between cosmic rays and interstellar gas. As we continue to unravel the mysteries of the Whirlpool's gamma-ray halo, we're reminded of how much there is still to learn about the universe. This faint, enigmatic glow is a testament to the complexity of cosmic phenomena and the ingenuity required to study them. Next, we'll explore the rings of star formation within the Whirlpool Galaxy, where new stars are born in dazzling displays of cosmic creativity. Now, let's turn our attention to one of the most visually striking features of the Whirlpool Galaxy, its dazzling rings of star formation. These glowing rings, which encircle the galaxy's core, are not just beautiful to behold, they are also cosmic powerhouses where new stars are born in spectacular fashion. These rings are a testament to the dynamic processes that shape galaxies, and they offer a fascinating glimpse into the life cycle of stars. The formation of these star-forming rings is closely tied to the galaxy's structure and its interactions with its companion, NGC 5195. As the two galaxies gravitationally tug at each other, they create shockwaves that ripple through the whirlpool's gas and dust. These shockwaves compress the material, triggering the collapse of dense clouds and igniting the birth of new stars. The result is a series of bright, concentric rings where star formation is particularly intense. What makes these rings so prominent is their sheer scale and brightness. The young, hot stars within them emit vast amounts of ultraviolet light, which illuminates the surrounding gas and dust, creating the glowing rings we see. These regions are also rich in molecular clouds, vast reservoirs of gas and dust that serve as the raw materials for star formation. As these clouds collapse under their own gravity, they give rise to clusters of stars, some of which are among the most massive and luminous in the galaxy. Astronomers study these rings to understand the conditions that lead to such prolific star formation. By observing the distribution of gas, dust, and young stars, they can piece together the complex interplay of forces that drive these processes. The rings also provide clues about how galaxies evolve over time, as the stars born within them will eventually disperse, enriching the galaxy with heavy elements and shaping its future structure. The Whirlpool's star-forming rings are not just a cosmic spectacle, they are a window into the ongoing story of creation and transformation in the universe. As we marvel at their beauty, we're reminded of the incredible forces at work in the cosmos, shaping galaxies and giving rise to new generations of stars. Next, we'll explore the powerful cosmic winds that sweep through the Whirlpool Galaxy, shaping its destiny in ways we're only beginning to understand. Now, let's shift our gaze to another extraordinary force shaping the Whirlpool Galaxy, its powerful cosmic winds. These winds, composed of gas and dust, sweep through the galaxy with immense energy, sculpting its structure and influencing the birth of new stars. Unlike the gentle breezes we experience on Earth, these cosmic winds are driven by some of the most violent and energetic processes in the universe. The origins of these winds can be traced back to two primary sources: the intense radiation from young, massive stars and the explosive activity around the galaxy's supermassive black hole. When massive stars form, they emit tremendous amounts of radiation and stellar winds, which push surrounding gas and dust outward at incredible speeds. Similarly, the supermassive black hole at the galaxy's center can generate jets of particles and radiation, creating shock waves that propel material across vast distances. Together, these forces create a dynamic flow of gas and dust that permeates the galaxy. These cosmic winds play a crucial role in regulating star formation. On one hand, they can compress gas clouds, triggering the collapse of dense regions and igniting the birth of new stars. On the other hand, they can also blow away the raw materials needed for star formation, effectively quenching the process in certain areas. This delicate balance between creation and destruction is a key factor in shaping the galaxy's evolution. Astronomers study these winds to understand how they influence the distribution of gas and dust within the Whirlpool Galaxy. By observing the movement of these materials, they can map the wind's paths and measure their impact on star-forming regions. These observations reveal how cosmic winds act as both architects and destroyers, carving out voids in some areas while seeding new stars in others. The Whirlpool's cosmic winds are a reminder of the galaxy's dynamic nature. They highlight the interconnectedness of its various components, from the smallest gas clouds to the most massive stars and black holes. As we continue to explore these winds, we gain deeper insights into the forces that drive the evolution of galaxies like the Whirlpool. Next, we'll venture into the galaxy's darkest and most mysterious regions, where secrets of the cosmos may still be waiting to be uncovered. Now, as we approach the final mystery of the Whirlpool Galaxy, we turn our attention to its darkest and most enigmatic regions. These shadowy areas, cloaked in obscurity, hold secrets that challenge even the most advanced tools of modern astronomy. Unlike the bright, star-filled arms or the glowing core, these dark regions are defined by their absence of light, making them some of the most difficult features to study in the entire galaxy. What makes these dark regions so mysterious? For one, they are filled with dense clouds of cosmic dust and gas, which block the light from stars and other luminous objects behind them. This creates vast patches of darkness that seem to swallow the light, leaving astronomers with only faint clues about what lies within. These clouds are not just empty voids, though. They are often the birthplaces of new stars and planets, hidden from view until the dust clears or until powerful telescopes can peer through the obscuring layers. Studying these regions is no easy task. Traditional optical telescopes struggle to penetrate the thick dust, which absorbs visible light. Instead, astronomers rely on infrared and radio observations to uncover what lies beneath. Infrared light, for example, can pass through the dust, revealing the heat signatures of young stars and other hidden objects. Radio waves, on the other hand, can map the distribution of gas and dust, providing a clearer picture of the structures within these dark regions. One of the most intriguing possibilities is that these areas could harbor objects we've yet to discover. From rogue planets drifting in the darkness to faint, ancient stars nearing the end of their lives, the potential for new findings is immense. There's even speculation that some of these regions could contain exotic phenomena, such as isolated black holes or remnants of long-dead stars waiting to be detected. The challenge of studying these dark regions lies not only in their obscurity but also in their complexity. The interplay of dust, gas, and magnetic fields creates a dynamic environment that defies simple explanations. Each observation adds a piece to the puzzle, but the full picture remains elusive. As we conclude our journey through the Whirlpool Galaxy's strange phenomena, these dark regions serve as a fitting reminder of how much we still have to learn. They embody the enduring mystery of the cosmos, inviting us to keep exploring, questioning, and discovering. With every new observation, we come closer to unraveling the secrets hidden in the shadows of this magnificent galaxy. And that brings us to the end of our exploration of the Whirlpool Galaxy's 30 most fascinating phenomena. From its supermassive black hole to its mysterious dark regions, this galaxy continues to captivate and challenge our understanding of the universe. If you enjoyed this cosmic journey, don't forget to like, subscribe, and hit the notification bell for more deep dives into the wonders of space. Until next time, keep looking up. As we wrap up our journey through the Whirlpool Galaxy's 30 most astonishing phenomena, it's clear that this cosmic wonder is a treasure trove of mysteries and marvels. From the colossal black hole at its heart to the intricate dance of its spiral arms, and from the explosive remnants of supernova to the enigmatic dark regions that defy our understanding, the Whirlpool Galaxy continues to captivate and challenge astronomers and enthusiasts alike. Each phenomenon we've explored reveals a piece of the galaxy's complex story, yet so much remains hidden, waiting to be uncovered. What makes the Whirlpool Galaxy truly unique is not just its beauty or its scale, but the sheer diversity of its features. It's a living laboratory where stars are born, galaxies collide, and cosmic forces shape the fabric of space and time. The interplay of light and darkness, creation and destruction, offers endless opportunities for discovery. And while we've made incredible strides in understanding this galaxy, the mysteries it holds remind us that the universe is vast and our journey of exploration is far from over. If this cosmic adventure has sparked your curiosity, let us know in the comments below. What phenomenon fascinated you the most? Are there other cosmic mysteries you'd like us to explore in future videos? Don't forget to hit the like button, subscribe to our channel, and ring the notification bell so you never miss out on our deep dives into the wonders of space. Together, let's keep unraveling the secrets of the universe, one galaxy at a time. Until next time, keep your eyes on the stars and your mind open to the infinite possibilities of the cosmos.